Hey, welcome back. So today we're gonna start learning LabView. So first thing first, open the LabView software that you have already installed in your laptop or your computer. So I have it open, but I'm gonna close and open it again so you'll see. It's gonna take a while, but it's gonna open. Yeah. So when you open LabView, this is the first screen, the first thing you'll see. You'll just wait, and this screen will pop up. You can just close this one. So here you have a bunch of tabs like File, Operate Tools, Help. Here you can click here and create a new project or a new program. You can click on each one of these, and it will take you to somewhere in the internet for you to see different things, like learn to use LabView and upgrade from previous version. Like if you have an older version, you can upgrade here. There's some community and support. It will take you to the forum that people discuss about their LabView problems and programs. Or if you need to find drivers or add-ons, you can do it here. So I'll talk about drivers later as we go on understanding LabView. You will have here the recent open LabView programs that you have recently opened. So what you're going to do right now is that you're going to click on File and a new VI. As I said in my very first video, every program that you build with LabView has a format of VI or virtual instrument. So for example, every text has a format of .txt. Every LabView program has a format of .vi. So we say open a new VI here, and you can open a new VI, and you can start programming what you want to program. So that's one thing that you can do, like if you want to start programming. So I'm gonna close this for now. I'm gonna come here. And so this is how you open a new program and start building your programming. If you go to Help and say Find Examples, this will open some currently saved examples in the library of LabView. So for example, if you want to understand a little bit more, or if you have some problems and some questions, and in the forum they are suggesting you to go and see the specific example that's going to help you solve your problem, you can do it this way. So just as something, just to show you like how LabView works and give you some like understanding, we're going to open an example, and I'm going to start talking about each one of the icons and bottom in that specific example, so you will have like a big picture of the LabView. So click on Analysis, Signal Processing, and Mathematics, and then come to Signal and Noise Generation. And then here open waveform generation using formula. You double click on it and it will open you a program. So this is what has been opened once you clicked on that specific example. So here you'll see a panel which is gridded. You can see all the grids here. This is called the front panel. You can see like here it says the front panel. This is the panel for the user. So when someone programs LabView, all the programmings happen in a second panel. But this panel, a front panel, is what users see. So not all the users know how to program a LabView. Maybe in your lab and you're working with LabView currently, and somebody else from like some other students or postdocs or a professor, maybe they have built a program and you are just a user and you're just running the program so that you can run a specific task. This is the front panel you will see. So that's only for the user. However, if you click on Window and click on Show Block Diagram, it will open you the other diagram, or the second window. And this is called the block diagram. So this is where all the coding happens. This is for the programmer. So the programmer codes in this window or in the block diagram for the user to go to the front panel and run a specific task. So every VI has two panels, a front panel and a block diagram. Front panel for the user, block diagram for the programmer. Programmer can also use the front panel for sure, but not all the users need to know what's happening on the block diagram. But here in this class, you are learning how to program with LabView. You're not just a user, but you're a programmer. So going back to the front panels, you can see here we have some information with this specific example. It says that this specific program demonstrates the use of formula waveform VI. What it requires is a LabView full development system, which for sure you have installed LabView so far. So the instruction says that select a formula value and run the VI. Note that if you select the invalid formula, the VI generates an error. Because this is a waveform, it's like it will generate a wave for you. It has to have a sign function like this, something similar to this. So let's run this. Like, it's basically what this program does is that it asks you to type a waveform equation, and then it will plot you how this equation looks like. So I'm not going to change anything here, but I'm just going to run it. So how can we run LabView? Here there are several icons. Like this icon, if I stand on it, it says run. So this is what it like if you want to run a program, this is where you have to click on the run. Here there is another icon says abort execution. So if you want to stop the program, you will click on this and it will stop it. This is the pause button. And here, if you look in here, you have some other icons. As we move forward in LabView, I will explain you what each one of these icons do. I don't want to give you all the information right now because you might forget as you move forward. But towards the process of learning LabView, you will understand each one of these icons because you have the need to know them. So far, just here is the run button, stop button, and the pause button. You rarely use the pause button. You always run and stop. So these two are really important. And here we have, file that you can save your file, and so some other icons. Again, as we move forward, I can explain what are the needs of each one of these icons. And so just know that here is the run button, here is the stop button, and if you click on Windows, show block diagram, it will take you to the other window, and again, Windows, show front panel, it will take you to the front panel. And there are also like Control E that you can click and then change the windows. So now let's run this. So if I click on run, this is what it will generate, the waveform of this equation. But you might have like some question, like what are like A, what is the A, what is the W, like nobody explained what is the A, what is the W, or for what duration you are running. All of this information, you can find them for this specific example are in the block diagram. So A is the amplitude, which is 1, frequency is 11, and then here is like some numbers that's going to explain you which duration or time this is running. I'm not gonna again tell you like how the LabView people program this example because we're gonna move forward, but just for now I'm just gonna give you a whole picture of the LabView. So just say that here for this specific example, A is 1, W is 2 pi multiply F, and the frequency is 11, and the time relates to some numbers that is already given to the program. So right now we're just gonna work with this front panel. Say you have this program and you want to like change things with this picture. Like if you click on it, you can see like these dash lines around it. That means that it's selected. And then right click, go to properties. Here are some information that you can change. For example, you can say that show graph palette. It will open you this thing. So if I click OK, this will give you the hands so that you can move it, you can see. Or these are like different zoom functions, like if you want to zoom on a specific data, you can zoom here, and if you click on the other one, you can bring it back, and here's for you to move the graph. So these are like some of the things that you can change with your waveform figure. And again, if you go to properties, there are some like display formats, so you can make it like a floating point for the numbers, scientific like SI notation, so you can play with this for the x-axis, and if you do it to the y-axis, you can also change it for the y-axis. So these are the things. And if you go to the plots, like you can say that, okay, I want to have markers, and I want the color of my lines, for example, to be like, I want to choose red, and my points, for example, to be like green. So yeah, you can play with these kind of things. And yeah, you can play like if you want to have major ticks, minor ticks, like what colors, you know, it's really similar to Excel. And here's a documentation, like you can say, give some information to it, say like this is a waveform, something like that, blah blah blah, and then you can just give this information and it will be saved. So whenever you're back and you want to see what this figure was, you can again go right click on properties, go to documentation, and see what you've typed. So this is the front panel, and this is what it does in this specific example. So for example, I can change the equation here. For example, if I delete this part, apparently this equation was bigger than that. But yeah, if I delete this part and if I say run, yeah, it's like doing some other things here. And if I say like give it some other like values or numbers or constant, like you can see how it's changing. So as long as this is a waveform kind of equation, so it has to be a valid formula, it's gonna run it. So this is the run button. Like whenever you run, like notice when I click on line for like several like milliseconds, you can see the screen is not gridded anymore. Like right now it's gridded, like you have to see the grids, the vertical and horizontal grids. So that means that this program is not running. But once I click on run, because this is only like something that just happens very fast, it just gets the formula with the information and constant numbers, and it's just gonna plot it, and it's gonna happen really fast. You cannot see what I mean, but if you pay close attention, you can see for like several milliseconds, the window here is not gridded anymore. Like see that during the time that is not gridded, it means that the LabView is running. Once the run is finished, it will go back to gridded. It will go back to a gridded window again. So this is like one way to see if the program is if a program is running or not. So if the front panel window, the grayish color is gridded, it means that the LabView is not running. But once it's like just gray colors, no grids, that means the LabView is running. Now I want to show you something else. So far I've showed you that we have this run button and the stop button. Sometimes when you build your program, the LabView program, and it's not built perfectly and there's some errors, like you forgot to add something to the LabView program that is required, this arrow is not this white arrow. So as an example, I'm gonna do something here in the block diagram in terms of like making it not nice. So I will add something and not add enough to it, so the program is wrong, and then I will show you what I mean. For example, if I add a case structure, which is like an if statement, I will explain all this later. Here you have to add like a reason for it. Like for example, in MATLAB we say that if the specific number is more than 2, then do this. So that specific number more than 2 is a constraint that is needed. So if you don't add the constraint for this if structure, it's an ill-made program. And here, if I go to show you, if you go to the front panel, you can see that this arrow button is crushed. It's like crushed in half. So that means that there is some list of errors. So you cannot run it. So if you click on that, it will tell you like what is the error for, and it's basically saying that there's some unwired constraints that you have to add. So that's another thing that I want to show you. And this also shows in the block diagram. So we have the run and stop buttons and pause buttons both in the stop panel, in the front panel, and in the block diagram. So now let's remove this. So I will right click on this and I will say remove case structure, and now it's again back to normal, and then you can run it again. So I want to show you some other things too. Here there is a bulb or highlight execution. So basically it will show you like the path that the program is running. So if I turn on the light and if I click on run, you can see like how these signals moved and then finished. So basically these are like wires or signals. I will go and explain all these things. But when you click on the bulb, you can see like how each one of these like signals are going to this function, and this function is going to create you the waveform or the graph. So I'll run it again, and let's pay close attention to this side. You can see like signals getting into the function and they are printing. So this is what the bulb button do here. If you want to see like how signals are adding and where they are going and which one happens first and later, this is it. As we move forward, I'll come up with an examples when you know how to build a block diagram to see how these things work. So now let's open a blank VI. So we go to File, a new VI or a new virtual instrument, and then it will open you, let me close this first. It will open you to windows, and you already know what each of these windows are, I guess. So it's a front panel. Here we are having the front panel, and we are having a block diagram, and I want to just make it so I can have both of them. Sorry. Okay. So in the front panel, if you right click, it will open you some controls. And controls are for the front panel are the things that you can add for the user to control what they wanted to do. For example, you can add a boolean, or you can add like a button, like an on and off button, or a toggle, or a switch, or like an LED bulb, something that the user can turn it on or off. So it can either be off or on, a true or a false situation. So something for the user to control. Or it can be, for example, like a slide or a gauge or a meter, like a tank. So something that the user can control here. It can also be some like decorations, like you can add a box or a circle, something that you put your like whatever controls you want the user to have over there, so that user can control them. So these are the things that a programmer can add in the front panel for the user to control the program. There are a lot of them here, and then based on your need you can add it. So once we move forward, we start adding different controls based on our need, and then you will see what they really do. On the other hand, in the block diagram, if I right click, there are some functions that will be opened, and those functions are like, for example, in MATLAB, the if statement, the while loop, the for loop. So these are the functions, the real mathematics and functions that are happening. For example, if I go to structures, it will open another window with all the structures that are inside, and you can see there's like a for loop, a while loop, a case structure, which is an if statement, a sequence. So for a sequence, you will have like a sequence of things happening. First number 1, then number 2, then number 3, something like that. And again, you can have like decorations if you want to. And we will have, there is also an array function, like an array function. I guess next week we will get to it. You can build arrays, vectors, and matrices for your program based on the need of your program. And so this is how it's going to help with the array and also here with the matrices. We have again a Boolean operation. Like over there we had a switch of the Boolean, like here. If I right click, there's a control of Boolean that there's like a push button. So this button, when you have it here, it will show you something here as the Boolean operation. So it can be either true or false. So when you turn it on, for example, it's true, or when you turn it off, it's, for example, false. We also have a numeric, like if you want to add things, subtract, multiply, or other things, or a comparison if it's larger or smaller, or a timing if you want to give it a delay or stopwatch, and an elapsed time, like so many cool functions that, for example, in MATLAB you have to write those functions, for example, as a stopwatch or something. Maybe MATLAB has those functions in them, I guess. But for example, in C++ or C in Java, you have to write the thing to happen because they don't have the already built-in function, for example, for a stopwatch. But here in LabView, these functions has been already made, so you don't have to code them. It already knows what to do. Like if you choose here the elapsed time function, it will ask you for how long you want the function to run, the program to run, and you will say, for example, 10 seconds, and it will automatically run the program for 10 seconds, and it will show you the time that is elapsing. So this is the cool thing about LabView, that you don't have to program everything in it, because there are some functions that you can just use and make it will have your program smaller and makes your life way easier. So there are some graphics, there are some like file transferring, writing the file to Excel. There are a lot of cool things. And then here, if you scroll down, there are some other things. Like if you go to mathematics, there are some, again, like mathematics that was already there, but there's also some other thing here which is really cool, and it's the script formula. And then if you go to the, for example, the script nodes, you will see the MATLAB script. And this is the cool thing about LabView, because you can connect MATLAB to LabView. For example, you have something that MATLAB can do, but LabView, the current version of LabView that you have, cannot do it unless you pay some extra money to add these add-ons or functions to your LabView. So this way you can connect MATLAB to LabView, and then you can run MATLAB on the background of the LabView and have your entire system running without having to pay something. For example, the last week we're going to talk about image processing, and image processing is something that LabView can do also, but you have to pay, I guess, around $5,000 to have this add-on to your LabView, and then LabView have this availability to run image processing. But say you don't want to spend $5,000, MATLAB has some kind of like image processing already there, which is for free, and so you can write your own code in MATLAB inside a LabView. So this is the good thing about MATLAB script here. So say that you have opens, so you cannot, for example, open these controls. If you want to open these controls and by right clicking you cannot see them, you can always go to view and then click on control palettes, and it will open the control palette for the front panel. And the same is true for the block diagram, because you will have some function palettes here, and if you go to view you can open the function palette here. So this is like if it's not opening. And if you want to look for something, for example, you want to open the while loop, but you cannot find it here, you can always go to search, and if you type the right name of it, for example, the while loop, it will show you the loop, and if you double click on it, it will show you where it is. So you can go like it's to programming and then structures, and then you can find it. So you can right click and say programming and then structures. Oh, here is my while loop. So this is a way of finding some functions if you cannot find them. But you can always Google and say that I cannot find this function, where it is, if you don't even know the name of it. So these are the things that I want to tell you about, like some preliminary thing about LabView so far. I'm gonna talk a little bit about like these things here. So these icons here are gonna align your objects. So if you have added so many booleans and so many like numerics like gauges and dials and tags, and you want to align them all, you can use like these icons, and you can really see like what it means. It will align from top, this aligns on the middle, and this is from the bottom, and you can start aligning your objects. And these are also like all for aligning if you want to make your window, your front panel, and your program clean. So I guess these were the things that I wanted to say like beginning of LabView. From next video we will start building some programs.